Good morning, Year 10. Today I want to talk about using quadratic simultaneous equations. I think I probably was calling them simultaneous quadratic equations, wasn't I, last week? Doesn't matter. I want to talk about using them with graphs. So that's my objective for today. And I want to look back at a couple of the problems that we looked at last week. This was, I think, the very first quadratic simultaneous equation problem that we solved. This one was already written as y equals, so we just replaced that y with 2x, lined it up, solved the quadratic, and we got our two solutions. But you might already have recognised these before we sort of solve them as equations, because if we think of them as functions rather than equations, and if we plotted the graph of these two functions, I hope you'd realise that this is a quadratic, so this is going to be a parabola, and this is a straight line. Y equals 2x, hasn't got a plus anything, so it goes through 0 on the y-axis and has a gradient of 2. In fact, have a look at this. I've plotted those two graphs. So I've plotted y equals x squared minus 4x plus 8. I used a graph plotting package rather than working out the coordinates. And here's y equals 2x, straight line, goes through 0 along 1 up 2. And the two intersect twice. They meet here, and they meet here. And surprise, surprise, the points where they meet, the x and the y values where they meet, well, they were the solutions that we got when we solved this problem last week. So one of the applications of quadratic simultaneous equations is telling you where two graphs meet. And that's quite important if, these are two things flying through the air and we want to know if they're going to collide with each other. Let's look at a second example from the ones we did last week. Here's another example from last week. So we solved this one. This was a harder one. If you remember, we rearranged the second equation as y equals and substituted it into the first one. But if you look at how we rearranged the second equation and rewrite it like that, this is exactly the same, just moved the minus 3x to the front, hopefully you recognise that that's a straight line as well. Goes through 2 on the y-axis, gradient of minus 3. Now, you won't have come across this function before, but actually, we did this in year 11, but this is the equation of a circle. So the blue line here is the curve that you get from this function. It's actually a circle. The green line is the straight line that we get from this function. Goes through 2, gradient of minus 3. And look, they meet twice. And if you look back in your notes, when we solved this question, we found two pairs of x and y values, and those were the coordinates of these 2 points here. I say again, this is just one application of simultaneous quadratic equations. So here's a question that looks a little different to the ones we were doing last week. The curve with the equation y equals x squared minus 4x minus 1, which we know is a parabola, crosses a straight line with the equation y equals 2x minus 1, which we know crosses the y-axis at minus 1 and has a gradient of 2. Crosses it in two places. Find the coordinates of these points. Well, it looks like a different question, but it isn't. It's exactly the same as the ones we were doing last week. We're solving these simultaneous equations. We're finding the values that satisfy both equations. So that's equation 1, that's equation 2, and this is one of the easy ones, isn't it? This equation is already written as y equals, so all I'm going to do is rewrite the first equation, replacing that y with 2x minus 1. 2x minus 1 equals... And then I'm just going to line this up. I'm going to get a 0 here, so I'm going to take away 2x and add 1 to both sides. So that's going to give me x squared minus 6x, plus nothing. That's good, because when I come to solve this equation now, I could use the formula. A is 1, b is minus 6, c is 0, but actually this is one of those special case factorizations. So it gives me the two solutions. X is 0 and x is 6. Now, we haven't done one of those since the Christmas holidays, so you might have been a bit rusty on that one, but if you remember, there were some special case factorizations, and we punch the air when we see that because we know it's an easy one. Okay, if only I had a nice easy way of finding out the y values Here we go. Y is equal to 2x minus 1, sorry. So when x is 0, 2 lots of nothing is nothing, take away 1. And when x is 2, 2 lots of nothing, 2 lots of 6, sorry, I'll start again. When x is 6, 2 lots of 6, take away 1, is 11. Now, last week we were getting to that point of saying, right, that's our answer. But what we can now say is, so they intersect, it's a good word for crossing, they intersect at, so this gives us one place, x is 0, y is minus 1, and this gives us another place, 6, 11. Now, if I go back to my original graph, which showed a parabola and a straight line crossing twice, let's just consider what would happen if we moved the straight line a bit. I mean, it is perfectly possible to have a straight line that never touches that graph. So that straight line there, for example, and I could draw any one of a number of straight lines which never crossed the red line. I could also draw a straight line which only touches it once. So this one doesn't touch it twice like the blue line, doesn't miss it altogether like the black line, it just touches it once. And this is the three scenarios for straight lines and curves crossing. The straight line will either cross the curve twice, it will miss it altogether, or it might touch it once. And if it touches it once, it has a special name. It's called a tangent to the curve. You might have heard the phrase going off at a tangent, but that line there, which just touches the curve once, is a tangent. Okay, so let's answer a couple of questions that relate to that then. So here we've got another problem, like the one we've just done, but we're not asked to find where the two lines cross, where the curve and the straight line cross. We're asked to show that they don't cross. So what I'd like you to do is I'd like you to go through the process that we went through with the one I did a moment ago. Again, it's a really easy one because you've got the second equation is written as y equals, so all you've got to do is to replace that with 4x plus 1 and try and solve the quadratic equation. Now, use the formula in this case and you're going to hit a problem. Okay, you're going to hit a problem. So have a go and see if you can realise what the problem you're going to hit is. Pause the video, I'll come back in a minute. Okay, so I made this equal to this. I then lined it up by taking away 4x, taking away 1. So that gave me that, and I'm going to solve it using the formula. So it's minus b plus or minus b squared minus 4 times a times c, all divided by 2a. I'm going to carry on solving it, so I've got minus 1 plus or minus 1 minus 4 divided by 2. 1 minus 4 is minus 3 divided by 2. Did you spot the problem? You cannot square root minus 3. There is no number which when you square it gives you a negative answer, so you can't then work in reverse. There is no negative number which you can square root. Now that doesn't mean we've made a mistake. All it shows is that this is an equation without a solution. And that shows that these two lines don't meet. There are no points that satisfy both equations. So I would stop at this point and I would say, so no solutions, meaning they don't intersect, or meaning that they don't intersect. And well done if you spotted that. Good stuff. Okay, so here's a slightly different question. We've still got a curve, slightly easy one now, and a straight line, and we've got to show not that they don't intersect, or not find where they do intersect, we've got to show that the straight line is a tangent to the curve. Now remember the definition of a tangent? It's a straight line that just touches the curve once. Now some of you will already see how we're going to do this, but I'm going to just go through the process. So let's start with the two equations. Second equation is already written as y equals, so I'm just going to replace that y with that. All of these are nice and easy like that today. Going to line it up by taking away 2x and adding 1. Okay, so I've got an equation. Now a quadratic equation. I'm now going to try and solve it, and I'm going to pause at that point. This one you can factorise quite easily, although some of you would prefer to use the formula, I know. Whichever way you prefer to use, try and solve that and see if you can tell me why your answer shows us that the line is a tangent to the curve. Pause now. Okay, so I don't know which way you went, whether you factorised or used the formula. If you factorised, you should have realised you got the same answer from both brackets. I'm not going to write it twice, it's the same answer. There's only one value of x, so there's only one solution. Sometimes it's called a repeated solution. If you use the formula, you got the same thing, because the square root is equal to 0, and the square root of 0 is 0. So whether you do 2 plus 0 or 2 minus 0, you get the same answer. You get 2 divided by 2, which is 1. So there's only one solution. Don't forget, we still need to work out our y value. Y is equal to 2x minus 1. So y is equal to 2 times 1, take away 1. Oh, it's 1 as well. What a coincidence. We get the same there. So what that means is the straight line and curve, straight line and curve intersect at 1, 1 only. The straight line and curve intersect at 1, 1 only, and this means that the straight line is a tangent to the curve. This means that the straight line is a tangent. Remember the three eventualities. Sometimes a straight line will cross a curve twice, sometimes it will miss it altogether, sometimes it will touch it just once, and in that case it's called a tangent. That's what we've got here. Okay, a final question, and I'm going to start this one off with you, and I'd like you to have a go and finish this yourself. So it's another tangent question. So we've got the straight line, simple one here, and the complicated one this time isn't a parabola, it's one of the circle equations. We don't need to worry about, understanding it's a circle at the moment. We just need to do the process that we've learned. So here are my two equations. Equation 1, equation 2. Equation 2 is already rearranged, so again that step isn't necessary. So I'm just going to substitute equation 2 into equation 1. So it's going to become x squared plus, instead of y, I'm going to write 2x minus 5. So 2x minus 5 squared equals 5. And then I'm going to grid that out and sort it out and solve the equation. It should be one answer only. Don't forget to work out the y value. And can I just remind you about one of my top tips for solving quadratic equations, a technique you can whip out a utility belt. If you can divide a quadratic equation, if you can divide everything by the same number, that will often make it simpler. Remember, you should have a 0 here, so 0 is your friend. Anyway, have a go at finishing that question off, and if you could submit your answer on OneNote, you'll see I've put this question on a page in OneNote in your homework folder, and hopefully you can finish it off and submit that. And I will see you again on Thursday.